Hey, Advanced Geometry. So I'm going to give this a go with the little webcam showing my face while it goes, and we'll see if that is any better. I don't know. We'll see. Okay, so you should have done those warm-up problems before you started playing. If you haven't, then please do that. So pause and do the 4. Okay, so what we're looking at here, you'll notice that these 4 problems have a lot in common, but fill in the blank here, we need a 25. So, and it's positive. With a positive 5 means this would have to be a positive 5. Really, there's no other option. So when you FOIL that out, though, you get x squared plus 5x plus 5x plus 25. Combine like terms, and that is not going to work. So not all the quadratic trinomials are actually factorable. So this one would be not factorable. And when we say that at the moment, that is really only for real numbers. But next year you'll get into ones where you can factor with imaginary numbers and irrational numbers, but we're not going to even deal with that right now. So we're just going to say it's not factorable. Number 2. So here again, it has to be a positive 25. So I would have another plus 5. Well, we just FOILed that over here. And obviously that did not work out to match this either. So this one is also not factorable. Okay, next. So here we have a positive 5, so this would have to be a negative 5 to get a negative 25. Okay, that changes things a bit. So we have minus 5x plus 5x, and then minus 25. Well, the minus 5x and the plus 5x actually will cancel out, and you end up with what you started with. So that one is factorable. It'd be x plus 5x minus 5. And the middle term disappeared or canceled out when you combined like terms. Okay, so then we get to the ones here with the number in front of x squared. Those are the really difficult ones. So the first thing you always want to look for here is you want to look for a GCF. Remember, GCF is greatest common factor. So if there was a 2 here, I would look to see if I could factor a 2 out of these guys and then bring that out front. It makes things a lot easier. Unfortunately, there is no 2 to factor out of here. So then you have to start just reasoning through this a little bit. X times something would have to be 2x squared. So I know this would have to be a 2x. Okay, next thing, so a different color, 25. So I know that this times this would have to be a 25. So this would have to be plus 5. And then we're just going to double check and see if that FOILs out and works out. So here I get x times 2x, which is 2x squared. And then x times 5 is 5x. And then here's where things get interesting. So this 5 has to be multiplied by that 2. So that's going to be 10x. And then 5 times 5, which is the 25. Okay, combine like terms. And that works out, matches what we started with. Okay, so this should fill in the blank with 2x plus 5, and then when you FOIL, that ends up matching. Okay, good job. So let me move me. Next on the notes, so there are some special cases that we can go through. Now, not to worry, all of the normal strategies that we've been doing here will also work for these special cases. But, you know, there's a little bit of a shortcut you can look for that helps a little bit. So we're actually going to work backwards a little bit. We're going to start with the factored form and then just talk about how you FOIL the factored form. And why did that do that? Okay. So what you want to do, a plus b squared, you actually do have to FOIL that. So you're going to have a plus b, and then rewrite it again times a plus b. That is a plus b squared. So you actually do have to FOIL this. It's not just a squared plus b squared. That is like a massive mistake that people make all the time. So when you FOIL, you get a times a, which is a squared, a times b, so that's ab, and then b times a, but I'm going to just write it again as ab, and then b times b, which is b squared. Okay, these guys are like terms, so you end up with a squared plus ab plus ab is 2ab, and then plus b squared. That's plus. Okay, same thing goes for here. So a minus b, and then you do need to FOIL. So you get a squared, and this time it's minus ab and minus ab, and then plus b squared because negative b times a negative b is a positive. Combine like terms, and that's minus 2ab plus b squared. Okay, so basically when you're factoring though, you're going to start with these guys and then factor it back to this form. Now, not to worry, there's nothing to memorize about that, so please don't try and memorize a formula for that because you're really just going to use the same methods we have been. Okay, you are still going to start with 2 parentheses, w times a w, those go there. Okay, we have a plus sign here. So that to multiply to be positive, but the combined like terms is negative, so we know these are both minus and minus. So what I'm going to do is just list out my factor pairs of 16 with minuses. So negative 1 times negative 16, negative 2 times a negative 8, and negative 4 times a negative 4. So the real trick here is if you notice that this C value is a perfect square, what I would do, don't think about it any differently, but what I would do is definitely try the 4 times 4 first. Okay, it's not always going to work, but it does in this case. So w times w is w squared. I'm just going to go through the FOIL real quick. Minus 4w, minus 4w, and then plus 16. And that obviously will combine to negative 8w. So the factored form would be w minus 4 times w minus 4. And then as we talked about up here, you can, let me just put a little red arrow over to here. Sorry, it's a little bit crammed. You can rewrite that as w minus 4 squared. So this is a perfectly fine answer. This is also a perfectly fine answer. Okay, but don't do anything differently. It's just that if you notice the 16 as a perfect square, then maybe try the 4 times 4 first. Okay, down here, so this is a difference of squares. You were going to start, again, we're working backwards again. We're starting with the factored form just to talk about it, but you got a squared and then minus a times b and then plus b times a, but I'm going to write it as a times b. And then this is positive times a negative, which is a negative b squared. Combine like terms. Now, these guys are going to cancel. Okay, so that becomes a squared minus b squared. So again, this is another special case, but like I said before, there's nothing new to memorize. You're just going to go through the same process. You have a d, you have a d, and these two guys have to multiply to a negative 25, but the combined like terms need to cancel. So again, if you notice it's a perfect square, I would try the 5 and the 5, because 5 times 5 is 25. Those are the square root of 25. So I would try that. Now with the negative, that means one of these is positive and one of them is negative. And this is just like what we did in the warm-up above, because you will get d squared minus 5d plus 5d and then minus 25. These are going to cancel and you end up with what you started with. Okay, so those are the special cases, but nothing new to memorize. All right, then we get to the grand finale here, which is the factoring when there is that number in front. We did one, an easier version in the warm-up. So first thing, you always want to check for that GCF. So for example, here we have a 3 in front. So if these other two terms have a 3 as a factor, we can factor out the 3 and then it makes it a normal factoring problem and it's no big deal. Unfortunately, 3 does not divide into 17 or 10, so we can't do that. So what you're going to do is you got to think about this times this has to be 3p squared. So you actually have to think about what are the factor pairs of 3. So in this case, 1 times 3, and that's it. And then for 10, let me do that in a different color. For 10, this times this still has to be 10. So those two last guys are still 10. So that's going to be 1, sorry, I don't know what's going on there. 1 times 10 or 2 times 5. Okay, everything's positive, so all my factor pairs are positive. Okay, and now we're just going to sort of check and guess and check and figure out which pairs are going to work. So generally, I put the 3, the number in the front in the first section, and then just p in the second. Doesn't matter really which way you go. Okay, now I can already see which one is going to work to get me a combined like terms of 17. But this just takes a lot of practice to know that. So I'm going to go through one that doesn't work and then go through the one that does work. So off to the side here, I'm going to just do 3p and the p. Okay, and then I'm going to put in the 2 and the 5. But I'm going to put, let's see, the 2 here and the 5 here. Okay, and that's my guess for how this is factored, because 3p times 3 is 3p squared, and 5 times 2 is 10. Now, what you have to do is go through and FOIL, and then we'll talk about the things you want to focus on. So that's going to be 3p squared, and then 3p times 2, which is 6p. Okay, then down here, we have 5p, and then 5 times 2, which is that 10 we knew we were going to get. Okay, when we combine like terms, we get 3p squared plus 11p plus 10. Okay, that obviously does not match. So that is not the correct factorization for this trinomial. But what I want you to notice is these combined like terms come from the outside pair and the inside pair. So a lot of times what I like to show people, I'm going to erase these other lines here and here. So what actually helps, I think, is focusing on this being multiplied and this being multiplied. Those two pairs are what combine to make that middle term. So whatever I put here is going to be multiplied by the 3, and whatever I put here is just multiplied by the 1. Okay, so when I put the 2 here, I got 6. When I put the 1 there, or 5 there, sorry, I got 5. And those added up to 11. Okay, so what I'm going to do is just flip-flop the 5 and the 2 and see if that helps. So now I have 3 times 5, which is 15p, and then 2 times p, which is 2p. And when I combine like terms, that is 17p, which is exactly what I wanted. So this is the correct factorization. Again, if you FOILed it out, you got p times, or 3p times p, which is 3p squared. You'd have the 15p and the 2p, which is 17p. And then you would have, lastly, the 2 times the 5. I don't know why this is freaking out like that. Equals the 10. Okay, now all of this stuff takes a lot of practice and some good number sense. So if you know your multiplication tables really well, then it's gonna, be a little bit easier for you. There are tricks that some teachers show. I'm not going to show that to you. I really do think that practicing your number sense with this kind of thing is super important. So I need you to sort of go through it in this method to start with. But this would be your final factorization. Okay, that's it. See you soon.